So today I'm going to talk about random walk, and random walk is a very important phenomena. Sorry, random walk is a very important concept to study various phenomena in physics like Brownian motion. There is another very important thing which we know about the random walk, the motion of a drunkard. So it's a very interesting concept that that in the study of random walk, we can appreciate the motion of a drunkard. As if we try to look at the motion of a drunkard carefully, then and where there is a person who is heavily drunkard, and if we try to look at its motion, a drunkard doesn't know whether he has to move forward or backward. Sometimes he moves forward, sometimes he moves towards left or sometimes towards right, or sometimes he may come back. So that's a very interesting motion. But during its journey, with the passage of time, he moves from one point to another point, and he will cover a certain distance, and that's a distance, and how it moves. Let us have a look at that. There is a drunkard person. He's sitting here. It will be somewhere here, and he's trying to move somewhere else. His destination is this. So he either may this way, this way, this way, this way, this way, this way, and keep on moving like this. And sooner or later he will arrive at this point. And sometimes like this, and he will reach it at this point. So that means this is the distance traveled by drunkard person to reach at this point. But its actual motion is this one, and it will take a lot of time. So if we try to look at Brownian motion or electron transport through metals, that is also looks like this. That means there are certain processes which involve motion of particles, which involve the which involves random motion of particles. And for example, the very important phenomena which we study in physics, it's the Brownian motion or electron transport through metals. These are two very typical examples which we study in physics. And if we try to look at the Brownian motion, what is the Brownian motion? Brownian motion, it is the random motion of particles suspended in fluid. Suspended in fluid. Fluid means a liquid or gas. Resulting from their collision collision with fast moving atoms or molecules in the gas or liquid, right? So this is the simple definition of Brownian motion. Means the particles, when they are suspended in fluid or in a liquid, fluid means a liquid or a gas, then they keep on colliding with themselves or other gas molecules, gas or the atom molecules in the fluid. And then they move randomly, and during this process, they will arrive at a certain distance. And their motion is random, and their motion looks like the motion of a drunkard. And there is a book on Drunkard Walk by Mlajinov, and if you go through that, that's a very beautiful book. So, to appreciate the Brownian motion, let us take another example. It's a very simple example. Suppose there is a room and inside the room I opened a bottle of perfume. I opened this up. This is the perfume bottle. And here is a person who is sitting at the another corner. Now when I open the bottle, what will happen? The molecules or the atoms come out of the perfume bottle, and then say there is a one particle and then another particle. That means it goes like this, and then keep on moving like this, sometimes this way. It keep on colliding with another particles, and with the passage of time, this particle reaches in this way. This tries to reaches at the nose of the observer. And the observer is sitting at another corner of the room, and it will take some time, and this is the radial distance which this has been distance. So our purpose, our objective in this, that how this radial distance can be calculated. So if we try to look at this motion or the such type of motion, then we can understand such type of motion of particles with the help of random walk. And to understand the random walk, our model is the motion of a drunkard. So if we try to see that the one-dimensional motion of a particle, if something is supposed to move along the one axis, along x-axis, then there is equal probability of the drunkard. Either this drunkard may go forward or it may come backward. So if there is a random number which is greater than 0.5, then the drunkard may move forward. And if this random number is less than, means if random number is less than 0.5, then it may go backward. And if random number is greater than 0.5, then we can say that the drunkard may move further. So sometimes this drunkard may move 3 steps and then it may go backward. Say it will go 3 steps and then come back 1 step and then 2 steps and then again it may go 2 steps forward and so on. It keep on moving like this. Either it may go forward or it may go backward. Right. So such type of motion of a drunkard will help us to understand uh, various concepts like the Brownian motion or the electron transport through metals, right? So this is a brief idea of random walk. So let us try to develop a mathematical model to understand the concept of this motion of a random walk. So it's a mathematical model to understand the concept of random walk. Say there is a particle situated at this point. This particle may go like this, and then this particle may go like this, and particle may go like this, and so on. Keep on doing in this way. Finally, the particle will reaches at this point, right? So that means the distance which this particle has moved. This is the distance. Let me take um, another right. So that means this is the radial distance this particle had moved. Means it moved from A point to B, and let me call this is the R distance, because the objective of the particle to be reached from A point to the B point through a radial distance R, and the particle will travel n steps to reach at this point, and particle moving randomly, particle moving randomly to arrive at point B. So now let us try to calculate the radial distance. So that means particle moves small distances because it's a two-dimensional motion. It's x-axis and it's a y-axis. So here the particle has moved delta x1 distance. This is the delta x1 and this is delta y1, and similarly it has moved this delta x2 and this is delta y2, and similarly this distance is delta x3, and let me call this as delta y3, and so on, and say this is the nth step which particle had moved. It is the delta xn, and it is delta yn. So this way it arrived at this point, and here it is the distance which particle had moved. It is delta y4 and it is delta x4, right? So this is the distance. So sometimes it may along positive x-axis, sometimes it move along the negative x-axis, because now here the particle has moved along the negative axis. Here the particle moved along the negative x-axis in this way, right? So let us apply a distance formula. So this r square can be changed in x. So delta x1, delta x2, delta x3, and so on, delta xn, its square. This is the net distance along the axis, and along y-axis this is delta y1, delta y2 plus delta y3. this is a simple formula for the radial distance, and so on delta yn whole square. And let me open it up. So if I open it, then I can write down this as delta x1 square, delta x2 square, and so on delta xn square plus delta y1 square, delta y2 square, and so on delta yn square, plus there are some mixed terms or the cross terms. It is because when I open it up, so there are some terms which comes out to be delta x1 delta x2 plus delta x1 delta x3, and so twice will also be there because it's a simple algebra, and so on, plus delta y1 delta y2, sorry, it's a twice of delta y1 and delta y3, and so on. But what will happen sometimes, it may go forward and the backward, so overall this crossed term may cancel or nearly become zero. So cross term will become nearly zero. So in other words, I can say that this r square is nearly equal to delta x1 square, delta x2 square, plus and so on delta xn square, plus delta y1 square, plus delta y2 square, and so on delta yn square. And let me do little algebra. It is equal to delta x1 square, delta x2 square, sorry, delta x1 square plus delta y1 square, right, plus delta x2 square plus delta y2 square, and so on. So this is the square of the distance at each step. So this we can write down as r1 square plus r2 square, and so on. So if I take average of this, so average of these distances, if I call it as each step is r square, it is the average value, and it has taken n steps, so it is multiplied with it. So r square can be written like this. So that means r can be calculated as n RMS, because this is the RMS value if I take its square root, right? So that means, how do I interpret this? Here RMS is average, or root mean squared step size, thus using the idea of random walk, we can calculate the radial distance of randomly moving particle after n steps. So this is the advantage of this random walk, or the idea of random walk. And very interestingly, the motion of a drunkard help us to understand this concept. So that's all for this lecture, and in the next lecture I will talk about radioactive simulations, and for simulating radioactive decay I will use the concept of again probability. So that's all for this lecture.